Hey everyone, welcome to the notes for our Introduction to Angles and Angle Edition. These notes are available on OMHS. You're welcome to download them and print them. If you download them, you want to make sure you click Enable Editing, so that way you can edit the PowerPoint to print how you like. You don't have to print it in color, or you can print multiple pages on one piece of multiple slides on one piece of paper. You have to just click that Enable Editing button to do that. If you want to follow along with the notes, or if you want to check the key later, you're also welcome to do that. Please note that you have to watch this play pause it to the very end and click Submit and Exit, or Save and Exit. At the very end, the very end of the video will stop and there will be a place for you to say that you've completed it. If you don't complete the whole thing, it's not going to mark it as complete on my end, and it's just going to look like it is in progress still. So make sure you watch the whole thing. All right. So we're going to talk about angles. Hopefully you've learned about angles before, but just in case, we'll define what an angle is. An angle is formed by two rays with a common endpoint. Whoops. Okay, so a ray with rays with a common endpoint. Let's review what a ray is just in case. A ray is a piece of a line that goes in one direction and it has this endpoint. So it's like if I took a line and I cut off a piece of it. The endpoint, and then it'll go in one direction. And we name a ray starting with its endpoint and in the direction it's going. So this ray right here starts at B and it goes in the direction of A. So the name of that ray is BA, and the symbol for ray is this little ray symbol above it. And that symbol will look the same for all rays, no matter which way it's going in the picture. This ray is going to be named ray BC. So we start with B because that's the endpoint, and it's going in the direction of C. And the symbol will look like this. Again, that symbol will always be pointing to the right, no matter what it looks like in the picture. The common endpoint is the vertex of the angle. So if I'm talking about the vertex of the angle, I'm talking about like the corner where those two rays meet, the common endpoint. They both had a common endpoint of B, so the vertex of that angle is B. You might hear the rays called the sides of the angle. And to name an angle, you're usually going to use 3 letters. The middle letter will always be the vertex. You can use a single letter if there's only one angle in the picture. Okay. So when referring to this measure over here, or when we're referring to the measure of an angle, you're going to use this little lowercase m. Okay, so this says the measure of angle ABC equals 60 degrees. I would name this angle, angle ABC. Notice that middle letter is the vertex. I could have also called this angle CBA, and that would have also been correct. You're going to see me, when I hand write my angle symbols, I like to put this little slash through it, a little arc, like that. Because later in the course, we're going to be talking about less than and greater than. I don't want my angle symbols to be confused with a less than symbol. When it's typing, it looks all nice and pretty. When I'm handwriting it, it's not as pretty. So I put the little arc through it so I don't get it confused. If I'm talking about how big or its measure, we put this little m out front. So the measure of angle ABC, that has to equal a number in degrees. Okay, and now you've learned these types of angles before, but just a review, we have acute angles, we have obtuse angles, we have right angles, and we have straight angles. I know that an angle is acute if it is less than 90 degrees. If it's obtuse, if it's less than 90, or I'm sorry, it's greater than 90, that's silly, greater than 90 degrees. It's also going to be less than 180. That might be one thing that you didn't really cover before. An obtuse angle is going to be greater than 90 degrees, but less than 180. A right angle is going to be exactly 90 degrees. And a straight angle is going to be exactly or equal to 180 degrees. Okay, we'll make that look a little neater. Say equal to 90. Okay. Note that in that right angle, you see this little box. This is the universal symbol for a right angle. So if you see that little box there, you can automatically know that this is 90 degrees. All right, and then we're going to talk about congruent angles, and we're going to be talking about congruent angles all year long. Now, if the measure of two angles is equal, then we're going to say that those angles are congruent. So in my picture over here, if the measure of angle A is equal to the measure of angle B, then I can say that those angles are congruent, and I would say that angle A is congruent to angle B. So when we're talking about their measures, we're talking about a number, and numbers are equal. If I'm just talking about their names, we would say that they're congruent. That's the difference between using an equal sign and a congruent symbol. If you're talking about their measure or the number of degrees that they are, we're going to use an equal. If we're just talking about their name, then we're going to use a congruent symbol. All right, so in example 1, let's practice some of this vocabulary. Let's name the vertex of this angle. Remember, the vertex is the common endpoint of the two rays. So in this case, that's point K. The sides of the angle, or the two rays that make the angle. Okay, remember, we name a ray starting with its endpoint. So I would say ray KL and ray KJ. Notice I'm using the ray symbols. And now we can name this angle 3 different ways. I like to name it with 3 letters. Okay. K is the vertex, so K is going to have to be the middle letter. So I could say angle JKL. I could say angle LKJ. Or I could name it by the vertex. It's the only angle in the picture, so I'm also allowed to call this angle K. Now to classify the angle, that's where it's asking, is it acute, obtuse, right, or straight? Clearly it's not a right angle. It's not making a line, so it's not a straight angle. And it's clearly bigger than 90 degrees. So we're going to call this an obtuse angle. I'd like you to try example 2. Go ahead and try example 2 now. Okay, so the name of the vertex of this angle, well, that's point S. The sides of my angle are rays SR and ray ST. I can name the angle by angle RST, angle TSR, or I could just call it angle S. That's silly, angle S. And then because I see that little box right there, I know that this is a right angle. This little box right here is showing that this is a right angle. It measures 90 degrees. All right, some more vocabulary. We've got angle bisectors. Remember that bisector means 2 sections. So an angle bisector is going to be breaking my angle into 2 equal sections. So for our definition here, an angle bisector is a ray that divides an angle into 2 congruent angles. In the diagram over here, ray BD is an angle bisector. So because it's an angle bisector, I know that angle ABD is going to be congruent to angle CBD. And in the picture, that's labeled here with these 2 arcs. Okay. So this little arc and this little arc are showing me that those 2 pieces are indeed congruent, or the same measure. Perpendicular lines are 2 lines that intersect. And they're going to intersect at a right angle. So when they intersect each other, they're forming right angles. The symbol for perpendicular, it looks like an upside down T. So in my diagram here, I would say that line L is perpendicular to line M. A perpendicular bisector is kind of both of these things at the same time, right? It's, well, maybe not an angle bisector. But the word bisector, right? Bisector means two equal sections, perpendicular, right angles. So a perpendicular bisector is a line, a segment, or a ray, and it's going to be perpendicular or forming right angles to a segment at its midpoint. That's where that bisector part comes from. That point in the middle, it's cutting PQ in half there. So in this diagram, line LM, that's the perpendicular bisector to segment PQ. LM is cutting PQ exactly in half, and it's forming a right angle, so it's a perpendicular bisector. All right, in example 3, there's a lot of stuff going on here, so let's talk about the markings that you see. All right, this little hash mark here is indicating that AB is congruent to BC. So whenever I have segments that are congruent, we label that with these little tick marks. When I have congruent angles, they get labeled with these little arcs. And they would match up. So like if I had one tick mark here, one tick mark here, those are congruent. If you see two tick marks and two tick marks, those are congruent, and so forth. All right, I also see this box here, which is telling me that I've got a right angle going on. Part A says, write another name for angle CBF. CBF is right here. I am not allowed to call this angle B right now, because B is part of many other angles in the picture. I cannot call this angle B. I'm going to have to name it with 3 letters. They already said CBF, so my only other option is FBC. And I got to make sure I use the angle symbol since I'm naming an angle. Name the sides of angle EBD. Let's find EBD. Oh, a lot going on here. All right, EBD. Here's EBD. That's the angle we're looking at. So the sides of that are going to be ray BE and ray BD. Classify angle ABC. Let's find that in the picture. ABC. Oh, look at that. That's a straight line. So that angle is a straight angle. Give an example of an obtuse angle. There's a few options here. Oh no. Oh poo. I just deleted all my work. Hold on. Technology is great here. This was angle FBC, BE. All right, we're back in business here. An example of an obtuse angle. I'm going to look at your EB. This is an obtuse angle. I could name that one EBC. If you thought of a different one, that's okay. There's quite a few obtuse angles in this picture. I'm going to pick angle EBC. Name 2 congruent angles. All right, 2 congruent angles. There's only one answer for this, really. See the arc here? So we're going to name this angle, and then this one arc. So then I'm going to name this angle. So we can say angle EBA and angle CBF. Notice I'm using the angle symbols when writing this. And the last one, name a perpendicular bisector. So as soon as it says perpendicular, I know that I want to look for a right angle. Bisector, I want to look for something intersecting a segment at exactly its midpoint. So here's my right angle. I know that these two pieces are congruent, so B has to be the midpoint of AC. So what is intersecting AC at a 90-degree angle? Ray BD. All right. Looking at example 4, I'd like you to try example 4. If you need to use a highlighter, colored pencils, or something to mark up the picture, please be my guest. Go ahead and try example 4. All right, go ahead and check your answers with the answers you see on the screen. If you have any questions about any of them, maybe put a star next to them to know to ask me during office hours. If you got the letters maybe reversed, so you wrote angle UTZ, that's okay. But if you're not sure or you have a question, just make a little note of that and come see me during office hours if you need some help. All right, now comes the big geometry stuff, the angle addition postulate. This is very similar to the segment addition postulate, but with angles. Segment addition said you have a small segment, you put them next to each other, and you get a big segment. This is the same idea, but with angles. You're going to have a small angle and another angle, and when you squish them right up against each other, they're going to form a big angle. So in my example here, I have one small angle, angle ABD, here it is. And another small angle here, angle DBC. And when I put them right next to each other, I get this bigger angle, angle ABC. So the angle addition postulate says you can take the measure of each one of these small guys and add them together. And when you add them together, you're going to get the measure of the big one. Okay. Sometimes it's easier to see an example. So here's a picture. And it says if the measure of angle ABD equals 48 degrees and the measure of angle DBC is 78 degrees, find the measure of angle ABC. It's a lot of letters. What I recommend doing is putting each piece of information in your picture. So the measure of angle ABD, this angle here, and I'm going to label it with 48 degrees. DBC, just follow the path. Put your pen on D, follow it to B, follow it to C. That is the angle we're talking about. That's 78 degrees. So angle ABC, here's A, here's B, here's C. That's the big angle. So I like to kind of do this. That's the whole big angle. I don't know what that is. So we can use our angle addition postulate. And it's the same picture as up here. So this is helpful. The measure of angle ABD, I'm just going to do this the long way. You don't have to do this step if you don't want to. But plus the measure of angle DBC, that's going to equal the measure of angle ABC. So then I can substitute what I know. Angle ABD is 48, measure of angle DBC is 78, and I don't know the measure of angle ABC, so I'm just going to leave it measure of angle ABC. Well, now I can just add these two together. And we've been working in degrees the whole time, so it's 126 degrees. That is the measure of angle ABC. Maybe they'll give us a different piece of information. So I'm just going to redraw the picture so I can write on it here. Let's see, A, B, C, D. All right, here's the picture. And it says that DBC is 74. So I'm going to put a 74 there. The measure of ABC, oh, hey, that was the big one. That's 119 degrees. Find the measure of ABD. Find that. If you like to make it an X or whatever, you can. But we know that when we have the two small angles added together, they're going to equal the big angle. So my question mark plus the other small angle is going to have to equal 119 degrees. And now I'll just do a little basic algebra, subtract 74 from both sides. The measure of angle ABD, which was the question mark, is equal to 45 degrees. Hopefully the examples made the definition make a little bit more sense. Okay. Of course, we're not going to get away with doing this without doing some algebra too. It's the same idea though. Here it says the measure of angle PQR is 141 degrees. I'm going to go ahead and put that right in my picture. PQR is that big angle. So I'm going to say, oh, the big angle is 141 degrees. And now I have everything I need to solve. A small angle plus small angle will equal big angle. So I can say 13x plus 4 plus 10x minus 1 equals 141. And at this point, we're just playing algebra. One of the steps that students tend to forget the most is the combining like terms. You got to do that first. So combine your x terms together. 13x plus 10x is 23x. Combine your not x values together. 4 minus 1 is 3. I'm going to subtract 3 from both sides. And then to get rid of that 23, we'll undo multiplication with division. 23 divided by 23 is 1, so I get 1x. And 138 divided by 23 is 6. So x equals 6. Now, to find the measure of angle PQS, I need to take my 6 and plug it back in. So the measure of angle PQS is represented with 13x plus 4. But we know that x is 6. So this is 13 times 6 plus 4. Hey, calculator. Okay, here's your calculator. 13 times 6 plus 4, you get 82. So the measure of angle PQS is 82 degrees. To find the measure of angle SQR, well, SQR is represented by 10x minus 1. We know that x is 6. 10 times 6 minus 1, 59. So the measure of angle SQR is 59 degrees. And if you wanted to check your answer, add these two together. They need to equal 141. Otherwise, you got the wrong answers because these have to add up to 141. And if you double check that, you'll see that they in fact do add up to 141. All right, in example 4, it says the measure of angle DEF is 7x plus 4. So we got to find that in our picture. Find D, find E, find F. Oh, that's the big angle. So I'm going to label the big angle 7x plus 4. The measure of DEG, so find your D, find your E, find your G. There it is. That's 5x plus 1. And the measure of angle GEF equals 23. There it is. Now we have everything we need to set up our equation. Small angle plus small angle equals big angle. All right, go ahead and use some algebra. Solve for x. All right, so you should have x equals 10. If you didn't get 10, double check your algebra work. If you can't find your mistake, you know you're welcome to reach out to me and we can work through it together. Oops. All right, so x equals 10. Now let's answer the rest of the question. The measure of angle DEG. Well, DEG is represented by 5x plus 1. So it'll be 5 times 10 plus 1. 51 degrees. The measure of angle DEF. Okay, well, DEF is 7x plus 4. 7 times 10 plus 4, 74. There we go. And a good way to check, well, we know this is 51 degrees. Go ahead and add 51 and 23. You better get 74. If you don't, then you made a mistake. Okay, nice. Moving on. The measure of angle JKM is 43 degrees. The measure of MKL is 8x minus 20. And the measure of angle JKL is 10x minus 11. Find the measure of each angle here. Try this one on your own. Try this one now. Okay, So hopefully you got x equals 17. You should have gotten the measure of angle MKL is 116 degrees, and the measure of angle JKL is 159 degrees. If you didn't get any of those correct, go ahead and pause the video and try it to see where you made your mistake. Did you set it up wrong? Did you combine your terms incorrectly? Maybe you added wrong. That would be silly, but it would definitely cause an incorrect answer. And then one other mistake that students make the biggest mistakes on the test, and this is so silly. They put the answers in the wrong spaces. So make sure, did you say that MKL is 116 and JKL is 159, or did you get that switched? If you got it switched and you enter it incorrectly on the test, I can't go in and give you credit for that. So make sure that you are putting the correct answer for what it's asking for. That's a silly mistake, but it's unfortunately one that I can't go in and give you credit for later. So just double check, make sure, did you tell me the right number for the right angle? All right, sometimes they're gonna get a little tricky on us and start using vocabulary instead of numbers. And it's not really that tricky, you just gotta watch out for it. It says if the measure of angle DEF is a straight angle. This is fancy talk for it measures 180 degrees, right? Because that's what a straight angle is. So I'm just gonna go ahead and say, oh, this is 180 degrees. Angle DEG was 23x minus 3. And GEF is 12x plus 8. So this becomes the same type of problem. It's just instead of outright telling us what the measure of the big angle is, it tells us it's a straight angle. So since it's a straight angle, it measures 180. If it was a right angle, well, then you would know it was 90 degrees. In this case, it's straight angle, well, it's 180. Go ahead and set up your equation. Solve for x, and then tell me the measure of each of these three angles, being very careful that you give me the right number for the right angle. Go ahead and do that now. All right, how did you do? Check your answer with what you see on the screen. Okay, check your setup. Did you set it up correctly? Did you add small angle plus small angle equals 180? Did you combine your like terms correctly? Did you subtract 5 and then divide by 35? Or maybe you did something slightly different. But did you get x equals 5 at the end? If you did, yay for you, good job. And you took that 5 and you should plug it in for each of the expressions that we have and making sure that you enter the correct number for the correct angle. And they tried to be even trickier and they put angle DEF there. Well, we know that angle DEF is a straight angle, so it measures 180. And if you really want to check your work, go ahead and add these two together, 112 and 68. They have to add to 180 for our answer to be correct. All right, we've got another example here. Go ahead and try this one. Try this example. Okay, so when you set up your equation, you should have small angle plus small angle equals big angle. In other words, 5x plus 3 plus 10x minus 5 equals 17x minus 16. Combine your like terms. 5x and 10x together make 15x. 5x, 10x, that's where the 15x came from. A positive 3 and a negative 5 gives me a negative 2. There was nothing to combine on the right side, so I just leave it 17x minus 16. Now at this point, there's 4 different ways that you could have gone about solving this. I like to work with my x's first. If you did it differently, you're probably right, as long as you got 7 at the end. But I subtracted 15x from both sides. That left me with negative 2 over here on the left, a 2x minus 16 on the right. Add 16 to both sides to get those 2 x's by themselves. You get 14 equals 2x, and then I divided by 2. You may have done your algebra slightly differently than me, and that's okay. As long as you got x equals 7 at the end, then you did it right. If this algebra is proving to be a little bit more challenging than you were expecting, maybe you use a different method to solve. That's why I showed you how to use Desmos to solve the equations back in the Get Ready for Geometry. If that's something you'd like to review or you'd like to go over with me, let me know. You're welcome to go back and review the How to Use Desmos video, or come join me in office hours and I can show you then also. Now that we know that x equals 7, I'm going to take that 7 and plug it in for all 3 of my expressions. So that tells me that TUW is 38 degrees, WUV 65 degrees, and the big angle TUV is 103 degrees. And if you really want to check that, which I highly recommend, go ahead and add 38 and 65. They'd better add up to 103. If they don't, then you know you made a mistake in finding your X or even evaluating the expressions. Please know that in all of your assessments, exit tickets, tests, all of that, you do not need to type in the degree symbol. That will already be included in the box. So it would say something like, the measure of angle TUW equals blank degrees. You don't need to put the degree symbol since it's already included on the screen for you. I try not to make you have to enter that degree symbol ever. So don't try to be fancy and enter it, because once you do, it's going to mark it wrong. If you think that you accidentally put the degree symbol and you shouldn't have, or vice versa, you think it's definitely correct, it was just some kind of typing it in issue, you know you can email me and I'll double check it, look at it for you. And if you really did get it right, I'll always make sure that you get the points. All right, let's look at the next one. All right, your attendance quiz word today is measure. Your attendance word today is measure. Write that down. No period, just the word. MEASURE. The attendance word today is measure. The attendance quiz will close 1 week from today at 11 a.m. Okay, so the attendance quiz will close 1 week from September 20th. Okay, at 11 a.m. So just do that as soon as you finish this video. That way you can get the credit for it. Attendance word today is measure. There it is. All right, number 9. Okay, the picture looks like there's a lot going on. These problems are best if you take them one step at a time. You know, I think that could be said for a lot of things in life. Just one step at a time. Do what we've been doing. The measure of angle ABF is 6x plus 26. So find A, find B, find F. That's this angle down here. That's 6x plus 26. I'm going to go ahead and put 6x plus 26 right there. The measure of angle EBF. EBF, there it is 2x minus 9. It's a little angle, but it's there. ABE, interesting. Okay, whenever it names an angle like this and you're not sure, is it this angle or is it this one? Always go for the one that's less than 180, at least for this class. Maybe when you're in like trig or calculus, they'll tell you to go the other way. But for right now, if you're not sure, well, which way do I go? Always pick the one that's less than 180. So we're going to go A, B, E here. So this is 11x minus 31. Let's find the measure of angle ABF. So by taking this just one step at a time, labeling what they told us, I can actually ignore this whole top part. This whole part up here means nothing to us, and we can look at just this angle. Small angle plus small angle equals big angle. We're looking for the measure of angle ABF. So we're going to solve for x, and then we're going to plug it into this expression here. Let's combine our like terms. I like to work with the x's first. Maybe you like to work with the non-x's first. Either way. Let's add 31 to both sides. And divide by 3. All right, x equals 16. Wonderful. Now all we have to do is find the measure of angle ABF. We're going to take that 16 and just plug it in for x and evaluate that expression, 122 degrees. If this was a multiple choice test, I guarantee you that 16 would have been one of the options there. So just be really careful that you're answering the question. Angle ABF was this angle right here. So that's why we have to plug it into 6x plus 26. All right, one more example using all of the vocabulary that we've essentially talked about today. And again, just one step at a time. If ray BD bisects angle CBE, remember bisect means two equal parts. So we're going to find BD in our picture, here it is, and find angle CBE, here it is. And it's telling me that BD bisects this big angle. So it's cutting it into two equal parts. So I'm going to label those two angles as the same or congruent. The next part says that BC is perpendicular to BA. Okay. We're going to find BC. Here it is. And it's perpendicular to BA. Remember, perpendicular means that they intersect at right angles. So this is a right angle, that's 90 degrees. The measure of angle CBD, here's C, here's B, here's D. That angle is 3x plus 25. And the measure of DBE, here's D, here's B, here's E, okay, is 7x minus 17, or 19, there we go. Find the measure of angle ABD. We're going to find this guy. Okay, now knowing that this angle right here is congruent to this one, congruent means the measures are the same. So I can say that this expression and this expression have to be equal since those angles are congruent. Now I can solve for x, minus 3x on both sides. Add a 19 to both sides. And divide by 4. So 11 equals x. Now I can take that x and plug it in here. 3 times 11 plus 25. Well, 3 times 11 plus 25 is 58. So, and I know this angle is 90. So together, I can find the measure of angle ABD. That's the big angle that's made up of the 90-degree angle and the 58-degree angle that we just found. So what do we get there? 148. Okay, so we had to know what bisect means. We had to know what perpendicular means. We had to know that bisect two equal parts means that the expressions are equal. And we had to use the angle addition postulate. That was fun. All right, don't forget to do your exit ticket. Don't forget to do the attendance quiz. If you have any questions, please join me in office hours. I'm happy to help. I want to help. So let me know if there's anything I can do for you. Have a lovely day, guys.